Took over. It did? Oh.
Please put those 4 points on here. When they are done, sketch 4 different angles in standard position. If you do not remember what standard position is, then you should have been paying attention in the bell rings when I put up all the answers to the work I gave you this last night. It is, of course, recorded because I start work when work starts work. The green circle is there for something different. Do not worry about it yet. Everybody, do not worry about the circle yet. You should have the 4 lines and the 4 points. Yes? Excellent. Now, if we were going to do trigonometry, we need our reference angles. Yes? Our reference angles are formed, as always, by creating 90-degree angles with the x-axis. Yes? Everyone agree? All right. How far is this distance? 3. Excellent. How far is this distance? 4. Excellent. How far is the, automatically, without even thinking about it, how long is the hypotenuse? 5. Everybody cool? All right. How long is this distance? -3. Oops. Hold up. Negative 3. How long is this distance? 4. How long is this distance? Think. I'll wait a while for you to think about it. All right, what is it? No, you don't go to your calculator for 3 squared plus 4 squared. What is it? 5. Why is it 5? Ashni. When negative 3 multiplies by negative 3, it becomes positive 9. 4 times 4 is positive 16. 9 plus 16 is 25. The square root of 25 is 5. So this is 5. Yeah? Excellent. What is this distance? Negative 3. What is this distance? Negative 4. What is this distance? 5. What is this distance? Negative 4. What is this distance? 3. What is the hypotenuse? 5. What do you notice? What is sine of this black angle? 4 over 5. Right? Okay. What is the sine of the red reference angle? Pardon, Toya? Of course it's 4 over 5, because sine is opposite over hypotenuse. What is the sine of the blue reference angle? Negative 4 over 5. And what is the sine of the green reference angle? Excellent. What is the cosine of the black reference angle? What is the cosine of the red reference angle? What is the cosine of the blue reference angle? And what is the cosine of the green reference angle? What is the tangent of the black reference angle? What is the tangent of the red reference angle? What is the tangent of the blue reference angle? Would I be writing it down if you guys were saying the right answer? So is it negative 4 over negative 3? 4 over 3. Thank you. And the cosine of the green reference angle? Or tangent of the green reference angle? What do you notice about everything in yellow? What do you notice about everything in green? Well, there's something, everything in yellow is positive, but everything in green is also positive, and there's something else special about it. What is it? I'll give you a hint. It has to do with the color again. They're all the black ones. Where are all the black ones? In the first quadrant. Yes? What do you notice about the yellow one here? What's the only positive sign? It's in the second quadrant. What's the only positive cosine? Or the only positive tan, sorry. Third quadrant. Where's the only positive cosine? Fourth quadrant. Everybody see this? All right. This gives us a new way to look at sine. What do you notice about that, 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 and that? And that. The things colored blue work together. The things colored green work together. What do you notice? Pardon me? Well, that explains why my coffee's leaking. The little O-ring is gone. It does. It's a pain in the ass. What do you notice about the 4? Since nobody is finding it yet, I will stress, look to the left. They're all kind of dirty. Look. Okay, I'll take away the left. Look at that. Thank you. What do you notice about every single sine measurement? In sine, it's x and y. It's y over s.
Oh, yeah,
S? Slant. Oh, interesting. Bring back the first unit. Well done. But it's not x, is it? Yeah, okay. So it's s. What would be better than saying s? Hypotenuse. Sine is also when I have x comma y, sine equals y over hypotenuse. What do you notice about cos? X over hypotenuse. What do you notice about tan? Y over x. And what do you notice about how to find an hypotenuse? This one's a little trickier. X squared plus y squared root. Yeah? Everybody good? Okay, now, remember I told you we drew that little circle there, right? You didn't draw it, or did you? Good. That little circle is what we call the unit circle. And it's called a unit circle because we're going to draw it on this big one, but not like that. Oh, why not? No, you don't have to draw it thick and pink. Or giant. Well, I don't care how giant you make it. Ah!
Are you okay?
Selena, am I okay? Hit my hand on something. Oh, now my computer's not working. Draw a circle on the big Cartesian plane, please, ladies and gentlemen. All right, that is what we call the unit circle. Please draw one radius. That radius has a value of 1. That is why we call it the unit circle, because its radius is one single unit. Everybody cool? So no matter where I draw a line, what's the value going to be? 1. Excellent. When it meets the circle, it creates a 90-degree triangle, yes? This point, no matter what, on the Cartesian plane is x comma y, yes? Which means this value is y, this value is x. Since they are both positive in this quadrant, quadrant 1, all trig ratios are positive. Everybody cool? All right. When I come over here, negative x, y. Y, negative x, 1. So over here in quadrant 2, only sine is positive. Yeah? Finish off the drawing. Yeah? I'm not going ahead. I'm just seeing if everybody's cool with that. Is everybody good? Now, I'm going to shrink this down a little so I have a little more space to work with. This sets up another piece of mnemonic device, or another mnemonic device like SOHCAHTOA. Okay? Let's go with a nice, solid, light green. What letter is that? C. What letter is that? What letter is that? What letter is that? Cast. Because remember, in trig, we go counterclockwise for positive angles, yes? And if you go counterclockwise, you get the word cast, which will tell you if you have a positive sign, you are dealing with either all or quadrant 2 for sine. Everybody good? If you have a positive tan, what 2 quadrants can you be dealing with? 3 and 1. If you have a positive cosine, what 2 are you dealing with? 1 and 4. Everybody cool? Everybody can now use x's and y's as well as opposites and adjacents to do trig. Yes? Everyone sees it? Why this is y over 1? Everyone is good? And everybody understands this part right here? That our hypotenuse is just our x value squared plus our y value squared. Everyone's cool? I don't believe you. But that's okay, because as always, we're going to practice it. And everybody will be cool until I say, now do it yourself. And then it will be, oh, but that's okay. That's what we're here for. Turn the page over. What do I have all the way across there? What are every one of those numbers? They are points, which means they are all what? Yes, which means they are all either x's or y's, yes? Excellent. So that means we should be able to do the sine, cosine, tan of all of them. Before you do sine, cosine, tan, what must you find? You don't need a triangle anymore. Remember, that's what we just taught. Right? That is what we just discussed. Remember? And everyone said they were cool. Right? But you don't need a triangle because sine is y over h. Whatever the y value is over h is sine. Whatever the x value is over h is cos. Whatever the y value over the x value is tan. And how do you find the hypotenuse? X squared plus y squared. Okay? So, remember when I asked if everyone was cool? Is everyone cool? All right. So, what is that number right there? X. What is that right there? Y. Which means we can now do this, can't we? Before we do trig with x's and y's, though, what must we do? Before we do any trig, we must find the hypotenuse, which is what? Hypotenuse equals the square root of x squared plus y squared, right? Well, what is x squared? What's 0 squared? So what is 4? So the hypotenuse is 4, yes? So now we know our hypotenuse. Sine equals y over h. What is it? 0 over 4. So my sine must equal 0. Everybody cool? That doesn't make much sense to you, does it? But according to math, that's what it has to be, right? Because we just proved 4 times that sine is y over h, right? Okay. What is cos? Which is? Cos is x over h, so it's 4 over 4, which is 1. What is tan? Y over x, yes? 0 over 4, which is 0. Is everybody cool? All right. Now, if I were to ask you to draw it, what would it look like? Where is 4, 0? Out here, right there, yes? My terminal arm and my initial arm are right there, yeah? Did I go up at all? So what's the angle? 0. So if you go to your calculator and you push sine of 0, or, sorry, I lie, shift sine 0, what do you get? 0, right? Everybody good? Okay, now do that over here. What's the h? So, let's keep her going. Sine is what? Y over h, so 3 over 3, which is 1. What's cos? X over h, which is? X over h, which is 0 over 3, which is 0. And what is tan? Y over x, which is 3 over 0, which is no. No. You can't divide by 0. It's infinite, yes? So this is what we call undefined. Now, let's draw it. Oops, I'm encroaching onto C. I'll draw it down here. Where is 0, 3? Straight up there, yes? Making what angle? 90 degrees. What do we know about 90 from our SOHCAHTOA? Can we do tan of 90? No, we can't. The other two work. Everybody good? Okay, now, looking closely, there's a relationship here, isn't there? We've just flipped over to the other side of the x-axis, yes? Everyone understands? So we're going to be in quadrant 2, yes? So which of these is going to be the positive one? Sine. Why? Because of cast. Preston. It's 0x and it's up to 3. So, this one, what's our h? 5. We don't even need to do it, do we? Sine is y over h. So it is 0. Cos is, which is? What kind of one? Negative 1. Tan? Zero. Everybody good? Which makes that one 180. And then this guy, what's our h? 2. What's our sine? Negative 1. What's our cos? 0. What's our tan? Undefined. Because I can't divide by 0. Now, if we drew all these, we notice this one is 0, this one is 90. What's this one going to be? 180, 90, nothing. And what's this one going to be? If I go all the way around. Oh, sorry. 270, right? Everybody cool? Now, notice, please, what is the reference angle here? 90, undefined. What is the reference angle here? 90, undefined. Everybody cool? Those are the 4 major ones, right? 360, 90, 180, 270. Yeah? All right. Now, if you get that, and everybody does, then what changes if I change the x's and y's? Anything? Does my methodology change at all? No. What is the only thing that changes? The values. So, given a point P, negative 411 on the terminal arm, find the 3 trig ratios exactly and the angle of theta. So, read through that. What in there bothers you? There's one word in there that I have not used yet. I want to see if you can find it. Which is it? Exactly. What have we been doing up until now with Pythagoras? We've been using our square root button and rounding, yes? Is that going to be allowed anymore? No. So let's see what that means. First thing I would recommend is drawing it. I've been drawing in green. I will continue to draw in green. Where is negative 411? Second quadrant, because I'm over here at negative 4, and I am up here at 11. The point is negative 4, 11. Yes? Do I have an angle yet? No, I make the angle. Can I do trig on the theta side of it? No, where do I do the trig? On the reference angle side of it, yes? Now, did I need the drawing? No, because we know about the x's and y's now, don't we? But the drawing helps, because now I know that my sign is the only thing that can be positive, right? So if I do this and I come up with a negative sign, have I done it right? No. Would I hand it in to Mr. Myers? Of course not. So drawing will help. Is it necessary? Again, I say no. Would you, should, wrong ud sound. Should you do the drawing? Yes. Do I need to do the drawing, do you think? No, because I've done this a million times. All right, now, what do you know about the hypotenuse? If you had this drawing, you would do the square root of negative 4 squared plus 11 squared, yes? But without the drawing, you also know that the hypotenuse equals the square root of x squared plus y squared, yes? So even without the drawing, you could still do this. What is the hypotenuse? And this is where the new thing happens. What is the square root of negative 4? 16. What is the square root of 11? Or the square of 11? 121. What is 16 plus 121? 137. Is that a perfect square? No, so we leave it. Everybody understand? Okay, so now we have an h, yes? It is the square root of 137. If you have the drawing, it is really easy to do trig, isn't it? Opposite, adjacent, hypotenuse. Or x, y, hypotenuse. And does it matter which way you work this now? No. Whatever you need to do to tell me the 3 trig ratios, go. Either use the triangle or use x and y. Up to you. I must ask you to do some trig. That one was on purpose, but I have been known to snort when I laugh. I have a friend who is stunningly gorgeous. Like, if she walked by you on the street, all of you would stop for a second, like, the world is a better place. She's that pretty. No, she's absolutely beautiful. And she's got a wonderful personality. Wait for it. No, it's not my wife. My wife is absolutely beautiful with a wonderful personality too, but that's not who I'm speaking of, because the point of the story is about to happen. She is always smiling. She's a very happy person. And as you well know, if you are smiling, you are halfway to laughter, yes? Everyone would agree? So, she is always smiling. She sees you, her eyes light up, she smiles. If you make her laugh, the most beautiful one of the most beautiful people I know, immediately. That's how she laughs. I find it to be rather dichotomous. It is. Do we have an answer for me yet? No. Exactly.
11 divided by...
Okay. All right. So I've lost the plot here. Sine is x over or y over h. Yes? Agreed? What is y? 11. What is h? Square root of 137. Stop. That's the answer. Because as soon as you divide 11 by the square root of 137, this is an irrational number, which means the decimal goes on for how long? Ever and ever. What? Oops. It is not. It is 0.93979342335. Yes, of course more. I'm just out of room on the screen. So that is where we stop. What is the cosine? X over h, which is what? Negative 4 over square root of 137. And that's where we stop. What is the tan? Y over x, which now this one, can I do a decimal if I want? Because it is going to end, isn't it? But what would it be? Right. Now, can I put a negative there? Could I put a negative there?
No.
It won't change the value. Could I put one negative sign right in line with the division bar? Can I put negatives everywhere? No. Everybody understand? All right. Everyone is good? Please highlight exactly. We are going to be, when we do trig, we leave it exactly. Now, in the real world, can I go to Home Depot and say, I need some pipe to go the square root of 137 meters? Can I? No. So when in the real world, I would find this approximation, yes? But in trig, in math, we don't. We leave it exact. Just like in the first unit, how we stopped rounding pi and left it as pi. Is your hand up or are you stretching? Okay. All right, is everybody feeling good? Feeling strong? Fortunately, we're only on the second practice run. Here it is. Can you do it with the drawing? Can you do it with x and y?
Yeah.
What should you do in practice right now? Both. Go. Is everybody good with both methods? Please notice this method is essentially the first half of this unit, isn't it? Right? The only difference is we're adding a direction now. Yes? This, while it looks new and different because of this, it's not, is it? It's exactly the same thing. Is everybody cool? Doesn't usually go that smoothly. Okay. All right. Now let's take our knowledge and apply it in a different method. Or a different, not method, a different milieu. Because I know you're all about to go to French class. I know this because, of course, the first 10 minutes of my class was taken up with you learning your French dialogues, not math class. But that's okay. I, of course, know that when you are in Miss MJ's class, you are working on trigonometry. Of course you're not. Lies. Might I suggest that you work on French dans la salle de classe de français et tu travailles mathématiques dans la salle de classe de mathématiques. Ma français est peu. Je ne sais pas. Parce que mon français est mais très meilleur de l'homme average. Go. As soon as you see that, what do you know you have? One of those is what? Y. One of them is x, yes? Now, since it's negative, one of those must be negative, right? Well, how do you know which one it is? Because it's in the second quadrant. So you draw it. It must be over here, yes? Which of those two is negative? The x. So here is negative 9. And what is this? 5. Agreed? Everyone agree? Other way around.
Yeah.
Yep, sorry. Other way around. Other way around. There's the 9 and there's the -5. Is everybody good there? Excellent. Now, I want the value of the standard position angle. What have I built here? I have built a reference angle, haven't I? Now, you are intelligent young people. What finds us an angle when we have our opposite and adjacent? Shift tan. So if I do shift tan of what? 9 divided by -5, what will I get on my calculator? Clear, 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 clear. Shift tan of what? -9 divided by 5.
No, it's 9 divided by
9 divided by 5. -9 divided by 5. Okay, ladies and gentlemen, thank you. What is 4 divided by -2? -2. What is -4 divided by +2? -2. Does the order of this matter? No. What do I get? My calculator gives me -61, yes? Which means, where is that 61? There, right? Why is it negative? Because I went clockwise for my reference angle, yes? If this is 61, what is my theta? Well, 180 minus 61, which is 119. Now, observe. 9 divided by, oh wait, that's just -9 divided by 5. Huh? Yeah? Everybody good? Everyone can see that? Okay. Tan of 119. -1.8. Everybody good? Tan of -61. What's it going to be? What's it going to be? -1.8. Is everybody good? Why? Because that line is both of those things. Is everyone cool? Yeah? Okay. Now, I would like for you to use your calculator to do these. It will take you 2 seconds. Go. Because my computer's frozen. By the time it's unfrozen, you should have all those answers. What do you notice about some of those values? What do you notice about some of the values? Well, actually, you should notice about all the values. They match up, don't they? Right? You can see that 68.6820 gives me sine 43, yes? What do you see in E and F? Same numbers, but different value, yeah? It's positive because we're in quadrant 1, right? Where am I in 223? Quadrant 3, right? If this is 43, what must this be? It's still just 43 degrees, right? Because a degree is just a degree, right? What about this one? It's over there, and what's this? 43. Please notice the reference angles all share the digits. The only thing they don't share is the value. Everybody with me? So when you do cos, that is going to be right there, yes? And this is going to be 10. Agreed? And you notice here, I have the same digits, but it's down here. So what must this be? 10. And it's positive because it's in the C quadrant. Is everybody cool? Tan of 10. There's 10. Tan of 190. Same digits. There's 10. And 270 is undefined. Why? Because it's a 90 degree. Everybody cool? Right? The reference angles will give me sine values, which will allow me to find actual theta. Is everyone good? Sweet! Let's do number 6, and then I'm going to give you your work for the weekend. Standard position angle, and I know it's sine. As soon as you see sine, what do you know? You know two things. What do you know? You know the hypotenuse is where? Which of those is hypotenuse? 5. What do you know about that one? It's opposite, or what's the other value? Y. Right? And since it's negative, that tells you it has to be in which quadrant? Has to be in 3. Sorry, I'll use Roman numerals. Has to be in quadrant 3 or 4. Agreed? So let's draw it. We know it's got to be in 3 or 4, yes? And we know the hypotenuse is always positive, yes? So, foom. Those both have to be 5, yes? And the y is negative 2. Yes? Everybody good? Harsh. I'm sorry, what? How do you get a negative number in quadrant 3? Negative 2. My favorite kind of questions. Everybody cool? Which means now, this is where it gets tricky. Where are my possible thetas? Or I lied, that's the wrong word. Damn. How many possible thetas do I have? 2. I might be that theta, or I might be that theta, yes? But what is going to be the same? The reference angle for both is going to be the same, isn't it? Can you tell me which theta I want, blue or green? Some people are going yes, some people are going no, and some people are doing this. And then they're doing this weird sort of diagonal thing, like they're at the night at the Roxbury, like that bad old movie. Can you tell me which one of those I want? Do you have enough information? No, of course not, because they're both going to be the same, aren't they? If I told you it's in quadrant 4, do I want green or blue theta? Green. Everybody with me? But I didn't tell you, so how many possible answers are there? 2. What are they? How do I find that theta? No, that finds me sine. How do I find the theta? Shift sign. Shift sign of -2 divided by 5. And what do I get? When I go to my calculator, shift sign -2 divided by 5. And what do I get? 23.57. So 24, yes? What is my reference angle then? 24, right? So is this 24? Yep. Is this 24? Yep. So what are my 2 possible angles? What is blue theta? $204. What is green theta? Pardon? How much? 136? 236? 336. The blue goes to that line, the green goes to that line. So green theta is 336 degrees, blue theta is 204. Is everybody good? What? Because that's what your calculator is showing you. Right? When you punch in -2/5, you get a sine of reference angle of -24. But you have to know what that means. Okay? Your calculator is measuring from here, because that is -24. But that's why we did all these other drawings, to show you that the reference angles are all going to be the same. Everybody good? All right. You have a long weekend in which I wish to see page 80 to 81 done. Now it says it's an assignment, but it's not, because you haven't had a chance to practice this enough. Right? If this was an 80-minute day, things might be different, but it's not. So this is just regular work. This is your practice for this particular thing. Everybody good? Somebody check something? Yeah, okay. After we go over this, expect a Genectigazoink on Tuesday on this kind of trig. All right? You people are 3, dip 10. You people on Monday, I expect page 8. Was it 80 to 81? Yes. 81 for Monday. And you will get a unit circle. No, I don't want to call it unit circle. I want to call it Cartesian trig Genectigazoink on Tuesday. I don't know. Today's Thursday. Everybody good? Yes, we do. This class, ladies and gentlemen, my good friend Marianne has just reminded me of something. This class, no, I lie.